So we're going to do direct variation. This is stuff you have done. It is actually going to be almost identical to finding slope. Well, not finding slope, but it's the same thing as slope, constant rate of change, and finding out if something is proportional. So, on page 81, you guys see it? You guys ready? All right, are you awake? No yawning. I'll make everyone tired. Ladies, are you ready?
Yeah.
All right, speed. The distance y a car travels after x hours can be represented by y equals 65x. The table and graph also represent the situation. So I got a question for you. I just said it. Let's see if you guys are paying attention. What does y stand for? No. What is y there for? What does y mean? The distance. Good job. Come on, guys. The distance. It says the distance y, which means y is how far you went. What does x represent? No. Hours. So x is how far you went at. Are you ready?
Yeah.
Not if you're facing Miss Garrett, because the board and the notes are the opposite direction. Sorry. See? See? You talk too much. You mess up your job. All right. So y stood for distance, right? The distance is how far you make it if you have been driving for so long. So if you drive for 3 hours, 4 hours, 5 hours, y is going to tell you how far away you got. So what do you think that 65 means? If y is how far you got and x is how long you were driving, what is 65? Not 65 hours. Think about it. We're driving, right? What is 65? What does the number 65 have to do with driving? Got it. That is saying that you can go so many miles by driving 65 miles for every hour. So they put that on the table. I'm going to edit this table. I'm going to add something to it. Up above, I want to put the number 1, just so you guys can see it. In 1 hour, how far are they going to drive? 65. How do you know? It says right there. They're going 65 miles per hour, which means somebody has gotten the car. They got on the highway where they don't have to stop. They don't have to slow down. They don't have to do anything. And they hit that nice little fun button that says cruise control, so you don't have to speed or, cause problems or get in trouble. Right? What did we do with this table last time you saw it? Last time you saw a table like this, for example, Friday.
Pick 2 numbers.
Well, that's slope. That could work. So pick 2 numbers. Yeah, pick 2 sets.
3.
So we picked this one, and what else?
2.
When we got this, what did you do? And some not even paying attention to what's going on up here. What did you do?
Y2 minus Y1.
What is your y2? Distance. So is it 130 or is it 195? 195 minus what's your y1? Divided by what's your x2? Minus what's your x1? What is 195 minus 130? Kind of disappointed in these 2 right here because you guys like sit here and you wait. So everyone else is going to keep their mouth quiet. We're going to make the boys who are refusing to move and do anything to help us out actually do something to help us out.
What's 195 minus 130? 51.
Yeah.
Nope.
65.
over. What did this show us? What do we call this? Slope. That is your slope. But is that the only thing we did with that table? No, in fact, we also did something. Well, you guys, I'm going to erase the circled parts. Do you guys remember doing this?
Yeah.
What did we do now?
Add 1.
That was adding 1. What about here? What about here? Add what?
55.
130 plus 55 is 195. You guys all sitting there with calculators. Use them. All right. The longer you guys take to actually pick up and try to do your own math, the longer it takes for us to get to our homework. We're gonna wait on the same 2 boys who don't want to answer us, who don't want to help out.
65.
What about here? What about there? Add 65. So what did we do with this adding 1 and this adding 65? Look in your notes. Get out those notebooks. Look in the notes where we did this stuff. What did we do? We didn't add. And still, I appreciate you guys helping, and I know you guys are doing great, but we still have certain students who just sit here and let everyone answer for them, and then they struggle and complain because it's too hard. So we're going to wait. I'll just hold your chair. Table, right? We found the difference, and then we did what? If you're not taking good notes, of course you're not going to help you. You got to be writing what I write down. All right, guys, help them out. What did we do with these 2 numbers now? So we set it up as y over x, and you have 65 over 1. What was that called? Is the constant rate of change and the slope the same thing? Yes, there's also one other thing I had you guys doing with all these numbers. On that table, way closer to the beginning of January, we sat here and said, okay, I'm going to take 130 divided by 2. That was the same as y over x. What is 130 divided by 2? What is 195 divided by 3? What is 260 divided by 4? 65. Aren't those all the same as saying 65 over 1? This was showing proportional. What can you tell me about the constant rate of change, the slope, and proportional? Look at all of them. What can you tell me about the constant rate of change, the slope, and the proportionality? They're all the same. Guess what? Your direct variation. This is the big one. If it is proportional, it is a direct variation. We also know that it is slope. We also know that it is a constant rate of change. So basically, everything you need to know to find if something is a direct variation or not, you already know how to do. The only thing I'm going to do is show you how to take it and write an equation using it. All I'm going to do is we're going to do it, repeat a lot of stuff, but the only new thing is learning how to write that. And it's actually very easy. All right? So look at number 1. It says fill in the blanks to find the constant ratio. You have 130 over 2. What should 195 be over?
95.
What's the 195 with? 3. What should be over 4?
1.
Now, if we divided these, that's however we got those 65s, right? So what is the constant ratio? 65 miles per hour. The car is driving at a rate of 65 miles per hour. The constant rate of change, or slope, is found using the y2 minus y1, x2 minus x1. What was our answer on that one? 65. Now, it's not on my screen, but it's question number 3 at the bottom, and you have already answered this question. What can you tell me about the constant rate of change, the slope, the proportionality? Guess what you're going to write on the line for number 3? They are all the same. Everything we have been talking about since we took that mid-chapter check is the same stuff. There is like very, very, very little changes between each one. So go ahead and take that page and turn it over. All right, so what we need to know, and I'm sorry about all my writing across it now. A linear relationship is a direct variation when the ratio of y to x is a constant k. So this is what's important. Y over x equals k. Thank you. We know it's a direct variation when y over x equals k every single time. We know it's proportional when y over x equals k. We know it's a slope or a constant rate of change when you have the change in y over the change in x equals k. All right? So there's a lot of vocab we have to talk about. And as a reminder, slope, for example, on this graph, what's the slope?
Y2 minus y1.
That's how you find it. That 2 is your slope. 2 is slope. And what that means is starting right here. See this dot? Means I go up 2 over 1, because that's a 2 over 1. Is the next dot on the line? So from here I go up 2 over 1. Is it on the line?
Yeah.
Up 2 over 1. Is it on the line?
Yeah.
This is what your slope does. It plots these points so that a way you can draw a straight line. All right. So when two variable quantities have a constant ratio, it is a direct variation. When it is constant, when it is proportional, it is a direct variation. Which means looking at this graph, what can you tell me about this graph? Don't look at the numbers on it. Look at the graph. Look at that line. What can you tell me about that line? That blue line specifically. It's what?
Proportional.
How do you know it's proportional?
It's right there.
It's straight and if it is straight and goes to the origin, you are correct. It is proportional, but it is also a direct variation. So there's two answers to that. A direct variation has a lot of names, or not a lot of names. It has a constant that has a lot of names. It has a constant variation. It has a constant proportionality. If you hear me ask you what is the constant, I mean, what is the constant proportionality, variation, whatever one you want to use, it all means the same thing. All right? Let's check out analytics. So yes, I understand. I know this is solved, but we're going to walk through step by step and see how they solved it. We have a graph. What can you tell me about this graph? What can you tell me about this graph? It's proportional. How do you know it's proportional? Straight line goes to the origin. It has to hit both of those. So we know it's proportional. Is it a direct variation? Yes. How do you know? What did you guys just say the graph was? Proportional. If it's proportional, is it a direct variation? Yes. But to prove it, what they did is look at this first point. What is the ordered pair for that first point? 5, 2. So we're going to set it up as y divided by x. Out of the ordered pair 5, 2, what is your y? 2. What is your x? Can you divide that? Yeah, you can. You can get a decimal. It's okay. What is 2 divided by 5? It's not 2.5. Take 2 divided by 5. All right. I'm going to make this very, very colorful. So I like to make things colorful. Look at this one. We're going to do the same thing. Y divided by x. What is your y? On this one?
10.
Your y? 4. You're always going to see this as x comma y. So y is the 4. What's your x? What's 4 divided by 10? 0.4. Look at your third one. This ordered pair, we're going to do the same thing. Y divided by x. What is your y? What is your x? Divide. Look at your last one. What is your y? What is your x? Divide. And what do you get? Are all of those the same? So are all of them proportional to each other? Yes. So you have proven 2 different ways that it is a direct variation. 1, because it is a straight line through the origin. 2, because they have a constant. It says determine the rate in inches per minute. This found you the rate. 0.4 inches per every minute. Okay. Does that make sense?
May I have your attention, please? Any 7th grade boys with the last name L through Z, please report to the weight room at this time. Any 7th grade boys with the last name L through Z, please report to the weight room at this time. Thank you.
Bye, boys. Yes, it's all the other boys in this class. Go. Bye. See ya. All right. What questions do we have? Nothing? Nothing? Are we ready to try letter A? You want to do it on your own or with me? All right. What kind of problem is letter A? Word problem. What's the first thing we do with any word problem? Who would like to read it? Sorry, I didn't see Maddie first.
2 minutes after a diver enters the water, he has descended 52 feet. After 5 minutes, he has descended 130 feet. At what rate is the scuba diver
Descending. What is the second thing we have to do with a word problem?
Identify the question.
Identify the question. Anna, what's that question? So I'm going to shorten that very, very, very short. It says what rate? We are looking for what is the rate. What's the third thing we have to find for word problems? Important facts. What is important to know about this word problem? What else? And what? After 5 minutes, what? 30 feet, is that it? That's right. Guys, I have a lot of students who do this. If you start a sentence with a number, you spell out the number. You don't use digits. But because of that, a lot of you guys tend to skip this first item, 2 minutes. Okay? That's all the important stuff. It's asking us what's the rate. We're going to find the rate just like we just found the one up here. A lot of dividing, right? A lot of y over x has to equal the same thing, has to equal k. So what is your y? You have 4 different numbers. Why 52? Because if you put it on a graph, if you would have graphed this, the x would be minutes. So we're going to put 52 feet over what? Few minutes. What do we do now? Divide. What are we dividing by? What is 52 divided by 2? 26. Remember, Miss Lomar gets picky. Huh? Yeah. But does that guarantee that we have a direct variation? Does that guarantee we are proportional? No. So we have to do it a second time. What's our second ratio we need to set up? And what are we going to do here? What is 130 feet divided by 5 minutes? So what is the rate?
26.
And this isn't quite, it's not asking it on this problem, but I'm going to show you guys something. That equation. To write an equation, you are always going to have y equals something times x. What do you think that something is? 26. If you find a constant, you put it right in front of the x. Make it the coefficient. That's all that equation requires. That way, if it now goes through and asks you, well, how deep will the diver be if he swims for 7 minutes? Could you find it? Is 7 the x or the y? 7 minutes is the y?
No.
It's the x, so you'd be able to substitute in 7 and so on. If they asked you how long was he swimming to get to 500 feet, where would the 500 go? The y, so you'd have 500 equals 26x in this equation. So, okay? Any questions on that? Does it look very difficult yet?
Yes.
Only because you just barely walked in, Annie. Okay? Otherwise, it's not really too horribly difficult, right? Basically, it's everything we've already done. Literally. So, do you remember how to tell me if something's proportional?
No.
Take y divided by x. That's all we did. Y divided by x every single time. If they equal the same amount, it's proportional. If not, it's not proportional. If it's proportional, you have a variation. All right, so now we're going to move on to a different style. Oh, this one is very easy. I like this one. This one is very, very, very easy. The example up here says the equation y equals 10x represents the amount of money y Julio earns in x hours of work. Identify the constant proportionality. Explain what it represents in this situation. So what does y represent? What does the y mean? Y is the money, right? What does x mean? So if Julio works so many hours, he gets so much money, right? What does 10 represent? Not hours. And not just money. I want you to go back, flip the page back. Go back to the last problem we just did. Not flip the page, but go back to the last problem we just did. What did you guys find on that? On letter A, what did you guys find? Letter A. What was the question on letter A? What is the rate? How did you answer that? You answered it with 26 feet per minute, right? Okay, and then I showed you how it goes into the equation, correct? Okay, now look at this one. What is this? It's not 10x. What is just this? 10. 10 what? What's the label? Money and hours. This k right here, you have y equals kx. This is your constant. That's your constant. That's your rate. That's your variation. That's whatever it's asking for. That's what it is. So if y is money and x is hours, then your k would be dollars per hour. So what is the rate of Julio's pay? $10 per hour. Which means Julio gets paid $10 for every hour. If you have an equation, that one's easy. Pick the number. That's your constant. Take the two labels and figure it out. Is it dollars per hour or is it hours per dollar? If you know what the y is, you should know how to set it up. Okay? Think you guys can do it with B? Try it. Letter B, try it. You can be the only boy in this class now. All right, did you guys get it? No. That was distracting. What is the number? Read the problem. Guess what it is? What is the constant? You literally just said it, Annie. What is the constant? Right? Did you back what? Find the labels. How many of us are confused on it? You just walked in. All right, guys, look at letter B. It says the distance y traveled in miles by the Chang family in x hours is represented by the equation y equals 55x. Identify the constant of proportionality. You have y over x. What is y? What's the label for y? Miles. What is the label for x? It's already an equation. What is the number? That's all you have to do. On an equation, it's simple. You find the number, you find the label, put them together. Does that help?
No.
Dagobert. Yeah, with the smile on your face.
Yeah, I'm on it.
All right, so number 3, that's going to be, I'm actually going to skip number 3. I'm going to go to letter C. And I have to set my page like this because it gives us everything we need for letter C. Guys, we have already been doing all of this. All of this. It says 2 pounds of cheese cost $8.40. Show the cost of 1, 2, 3, and 4 pounds of cheese. Is there a direct variation? And explain. What do you notice they gave us over on the side in the workspace? A graph and a... Why do you think they gave us a table? So we can fill it in. What do you think goes right underneath the weights? Just 2 pounds? It tells us the cost of 1, 2, 3, and 4 pounds. So what are we going to put here? 1, 2, 3, and 4 pounds. So now we've got to figure out the cost. How much does it cost for 1 pound? How do you guys know?
That's 2 pounds.
So we got to fix that. So let's fix that. Good catch. Because it says 2 pounds of cheese is $8.40. Okay, so what would 1 pound be? How do you get $4.20? Perfect. So how much would 3 pounds cost? How'd you get $12.80? Multiplied what? Yeah. 1 pound is $4.20. Take $4.20 times 3, and what do you get? $12.60. So how much would 4 pounds cost? What would you do? If you know how much 1 pound costs, take that amount and multiply it each time to get your new one. All right? Any questions on that? What do you think we're going to do next? I'm going to graph it. I hate this graph.
It doesn't have this.
Oh, and then it skip counts. So we have 1, and you have to figure out, he has about $4, he has about $5. We need somewhere close to this $4.20. So it's somewhere in there. 2, let's see, there's a 7, there's an 8, so we go to about an $8.40. Then we go 3 to about a $12.60, and 4 to 16. $80 would be right about there. Then what do I want to see you guys using?
A ruler or a straight edge.
A straight edge. Does it have to be a ruler?
No.
No. What does it have to have?
Straight edge.
A straight edge.
Can I borrow that piece? Can I borrow that piece?
I am rude. You should be used to that. Now I got all of these. And I got all of these, and they're all straight. Well, these are probably more straight. But I'm not a delivery, so. What can you tell me about that graph? How do you know it's proportional?
Because it's a straight line that goes through the origin.
Because it's a straight line that goes through the origin, so it's proportional. But the question asked, is there a direct variation? So what do you guys think? How do you know there's a direct variation? Good. Kimberly's got it. I don't know if everyone else does, because some of you are talking and some of you weren't paying attention.
What the heck?
So, good job. Now I'm going to make them repeat that. Do you know if it's a direct variation?
What's a direct variation?
Is it a direct variation?
Yeah.
How do you know it's a direct variation? because it's proportional. Annalise, direct variation means it's proportional. If it's proportional, it's a direct variation. That's basically what it means. A direct variation, if you think about those two words, direct and variation, variation means how it changes. That goes back to the constant rate of change. If it's a constant rate of change, so it always stays the same, then it's going to be proportional. Yes, thank you. Alright, so if it's proportional, it's a direct variation. If it's a direct variation, it's proportional. That's how those two go together. So, down here for letter C, what would you write? How do you know? Because it says to explain. So everybody should be writing that down. Is there a direct variation? And explain how you know. And maybe is not a good answer. No matter how many times you say it, dude. All right. So quick review. Some of you guys might need more when you're done. I will try to post this video as fast as possible. But before I even turn it off, I'm going to do a quick review because some of you guys were still looking at me like I had lost my ever-loving mind when I asked you certain questions. So what I want to do is very simple because this is the one that I think most of you girls will go, what? I don't get this. Does that have a direct variation?
Yes.
Why are you hesitant?
I don't know.
What do you guys think? Thumbs up, yes. Thumbs down, no. Does that have a direct variation? It's either up or down, not to the side. Up or down. Make a choice. Does it have Y?
Yeah.
Does it have an X?
Yes.
Does it have one number by the X?
Yes.
So it's direct variation. Your direct variation is 15. Does that one have a direct variation?
Yes.
What is it?
2.
This one's a little trickier. Does that have a direct variation?
Yes. No.
It has a constant rate of change. It's not a direct variation.
May I have your attention, please? Any seventh grade boy or girl who has not taken a picture, please report to the weight room.
That's why.
Any seventh grade
If
boy
we
or
add
girl
6
who
to
has
the
not
end, if
taken
we add anything to the end, it's not a direct variation. You guys will actually not be getting any of those. All of yours will literally be y equals 46x. What is the direct variation? 46. Now I'm going to add to this. I'm going to say that y is the miles. X is hours. What does 46 mean in this problem then?
36 miles per hour.
46 miles per hour. So on an equation, just pull out the number in the middle. That's it. Okay, does that clarify? Especially you girls that were here for that and got confused? Okay.
Oh, I think I know what it is.
Okay. So boys, because most of you guys have gone for that. If you see an equation, it's going to be y equals a number x. Your direct variation is the number. The label is the label for y followed by the label for x. So like this one. What was the number?
46.
What was the label for y?
Wait,
What was the label for y?
oh, mom.
What was the label for x?
Hours.
That's how you're going to answer that one.
Oh.
Otherwise, you're basically telling me is it proportional or not. All right? Boys, if you need help, please log on to the book website and watch the videos since you guys went in and out of here. Girls, same with you. You can also click on the resource. You can also talk to us while you're in class and email me while you're out of class. So your problems will be,
What we have homework?
yep, page 85 and 87.
¿Y Julio entregas la tarea?
No voy a hacer.
¿Ahorita? Y pásame antes que no lo terminé. No. Julio. ¿Es ese? ¿Y Julio? No. Nah, que Julio.
To make it nice and short and sweet, tell me if it's direct variation by telling me is it proportional. That's it.